Welcome to Spring LIB.
Hi, today we're looking at the equations of motions of a balance wheel. So the first thing we're going to do is put down the equation for the angular position of this balance wheel, which is just going to be theta equals capital theta. And this capital theta is going to be the amplitude times cosine of omega t. So next we want to find the angular velocity and angular acceleration. So to do that, we're going to take time derivatives. So I'm going to put theta dot, which means one time derivative has been taken. Of this is going to be equal to negative omega times capital theta times sine of omega t. If we take another derivative, we'll get the angular acceleration, and that's going to be equal to negative omega squared capital theta, that amplitude, times the cosine of omega t. Cool, so that's the first part of the question, is just finding these general expressions. The next part of the question wants us to look at the case that theta equals the amplitude, capital theta. So in that case, we can tell just by looking at that top equation that the cosine of omega t has to be equal to 1. In the case when the cosine of omega t is equal to 1, we know that the sine of omega t is going to be equal to 0. Because we know that, it's pretty simple to find the expressions for the angular velocity and angular acceleration at these points. We can say that theta dot is going to be equal to 0, because that sine is going to go to 0. And we can say that theta double dot, the angular acceleration, is going to be equal to negative omega squared times the amplitude. The next spot that we're going to look at is we're going to look at the case that theta is equal to the amplitude divided by 2. We're at half the amplitude. So the cosine in this case, cosine of omega t, is going to be equal to 1/2. Now, at this point, the sine could be equal to two different things, depending on whether the cosine is increasing or decreasing. But luckily, the problem tells us that the cosine is decreasing, so we know that the omega t is going to be 60 degrees. So sine of 60 degrees is going to be equal to root 3 over 2. So we can now plug all this back in and we can get more expressions. We can look at theta dot is going to be equal to negative omega times phi, not phi, rather capital theta, times root 3 divided by 2. And theta double dot, the angular acceleration, is going to be equal to negative omega squared times capital theta divided by 2, because we know that cosine is still going to be equal to 1/2. And that's how you look at and think about this problem. I hope that helped you out.